All right, so the last one we did was number 10, which was the 11th problem. So now we're on 27, which is the 12th.
Didn't you want to say something about 10?
Oh, yes, I know exactly what you're talking about. Yes, thank you. Everybody with me with how I could just do a regular chart, right? All right, so if my standard deviation is 0.3, then I don't know what this is, but this is 0.3 above that, which means this would be 0.6 above that. Same thing on this way, but negative. We got to the point where this, we already did this part on Friday. This gives us a z-score of what?
0.44.
So my red numbers are talking about what? Which is the definition of a what kind of score? Z-score. Number of standard deviation, the main definition of z-score. So my z-score is 0.44, which is almost halfway, but not halfway here. So I am almost halfway to being 0.3 above, but I am not yet halfway to being 0.3 above. Which one of these answers is not halfway to 0.3 above? Is this halfway to 0.3?
No.
So we'd already marked out these two. Am I more or less than halfway based off of this?
Less.
Just barely under half. So 0.3 was half of 0.3, 0.14, or 0.15, sorry. And you could do it just off of that without, I think some people would be better off making that connection than the way I did it where we stop in the middle of this equation because they wouldn't understand why we stopped there. I think some people would understand it better that way, which is just like the same thing we were saying, I just made a different connection. Questions about that? All right, so 27. I am more concerned with a lot of stuff about 27 that actually have nothing to do with 27, but could help you in other problems like this, kind of work your way out of it. So, not looking at the actual problem itself at all, or not considering what the problem actually asking about at all. The histograms below represent the distribution of 5 different data sets, each containing 28 integers from 1 through 7 inclusive. What does this part mean?
It includes 1 and 7.
Yes, relative to these graphs. Yes, that is the first important part, is that it includes 1 and includes 7. But how does that relate to my graphs? That's what that's trying to tell you. Now, is that going to help you do this problem at all? No, but there are reasons I'm making this point. What is that telling us? The sample size. So these graphs look blank, but I really know everything about these graphs because I can sit here and do this. How many are in this bar? There's 2, there's 3, there's 4, there's 5, there's 6, and there's 7. If I add up 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1, I'm going to get 28. So basically, if I looked at these like boxes, there's 28 of those boxes, 28 people represented in here. So actually looking at the question itself first, we want the largest standard deviation. So let me clear out of what I just talked about and I'll come back to it again at the end. The definition of standard deviation is what?
Distance away from the mean.
So we have to know where the mean is first. These last three are extremely easy. That's the mean, that's the mean, that's the mean. Now these, I probably couldn't figure out exactly. My middle is about here, but I've got more to the right, so I'd be slid higher a little bit, so maybe somewhere like in here. Same thing here, but maybe not slid as far, so it'd be closer to like this line. What we're doing when we do standard deviation is how much pull they have from the mean. So looking at these two, I only have two here, two, maybe three. What is their pull from the mean? How much weight do they have to pull from the mean? How far do they pull from the mean? What? If I'm here, how far did I pull from here?
None.
0. So these contribute 0. How many do I have that contribute 0? Not a lot. Here, how many do I have that contribute 0? A lot. So if I have a higher standard deviation, that means I have more that are contributing farther from the mean. So I could look at this now kind of as like 0, 1, 2, 3. And I don't have to look at it as positive, negative, because standard deviation is distance from the mean. Here, most of my weight is coming from this one, which is a pull of 0, which means it contributes nothing to distance from the mean. Whereas here, these contribute nothing from the mean, but I don't have very many of them. Between these two, C and E, which one has the higher standard deviation? E, because I have more pulling away and less pulling 0. Stay with me, I'm not getting a lot of response there.
Yeah.
These are a little bit harder to tell. You can definitely see that C is probably our smallest standard deviation here because I have so much contributing 0, right? I can compare between C and E. I can compare between D and E. Which one is higher between D and E?
E.
Which one?
E.
Here I have 0. I have very few contributing 0. Here I have a little bit more contributing 0. Are y'all with me on that? Kind of, yes, no? So which one is higher between D and E? This one is the highest. The way you can kind of think about it is I only have 2 contributing 0, but I have a lot contributing 3 away. Here, I have the same amount contributing 0 as I have contributing, well, each of my 3 away. Now, back to where I started. If you are in an exam, and this is why I started with talking about the stuff up there. If you're in an AP exam and you have finished with time that is left over, and you feel good about most of these problems, and this one is just bugging the crap out of you. Come back to where I started here. I could type in my calculator in a list 7, 7, 7, wait, no, 1, 1, 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, 2, 3, 3, 3, 3, 4, 4, 4, 4, 4, 5, 5, 5, 6, 6, 7, and have it calculate standard deviation for me. And then go to another one and do the same thing. Would that be worth your time going through this problem to stop and type all those numbers in? No. But if you are finished early and you are stuck and you are trying to get yourself out of it, that's an idea concept that you can get to. Or maybe you're like, I understand this association down here, and I get that D is the highest standard deviation of those, but something about these is just blowing my mind and I can't see that connection. You might type in just D and just B and see which one is higher. But do you understand how you can use this information to be able to plug it in your calculator and let your calculator do it? And that's the kind of thing I want you to understand is they're gonna give you a lot like this where they give you bars and they'll tell you like they're on the same scale. You can even make up these numbers if they say that they're on the same scale and use them to plug it in. But it would take time, so don't do it on your way going through, but that's a way to kind of get yourself out of a problem if you're stuck. Questions with that? Number 5, and this is our 13th problem. This is an extremely, extremely easy problem. This is a wording confusing problem. Sometimes I kind of glance ahead, especially if it's like super wordy. If I look down at my answer key or my answer choices really quick, it's trying to tell me that it's valid or not valid. So I'm probably looking at the what of this problem. What things would make the problem valid or invalid? Probably conditions. Now, you don't have to look ahead to know what you're dealing with, but sometimes I do that. All right, so city's interested in building a waste management facility in a certain area. 100 randomly selected residents were asked for in the random. Do you support the city's decision to build a waste management facility in their area? Of the 100 residents, 54 said no, 4 said yes, 42 had no opinion. We've got our confidence interval constructed from these data to estimate the portion of this area's residents who support building a waste management facility in their area. All right, this first one, because a sample size of more than 30 was used. What is that statement just there talking about? And which, so this is checking normal by central limit theorem. What kind of problem am I doing? Proportion. Does central limit theorem apply to proportions? And a lot of people across all my classes are having issues with that this year. It's just one of the little things that they're forgetting. B, the confidence interval is valid because each resident was asked the same question. Well, should they have asked them all the same question?
Yes.
Does that make it valid? No. So they're just kind of trying to throw you off with that one. The confidence interval is valid because no conditions are required for constructing a large sample confidence interval. Is that true?
No.
Confidence interval is not valid because the quantity n times p hat is too small. The confidence interval is not valid because no opinion was included as a response category for the question. This is where wording is trying to throw you off here. If I am dealing with proportions, I am concerned with, so when I check normal for proportions, how do I check normal for proportions? So I'm doing something with n times p hat, and I'm also dealing with something with n times what?
The inverse.
In words, in general, what does this mean? Successes, what does this mean? So why is that confusing?
Because there's 3 options.
There's 3 options, and this is the wording part that's confusing. There was one constructed to estimate the proportion of residents who support the building waste management facility. So just like when I roll a die, there are 6 options, but I can condense it to be success and failure. So what are they considering success in this situation?
Yeah.
Which means what are they considering failure? And that's where people are going to get confused. So my n times p hat would end up giving me what here? Just 4. So n times p hat is not greater than or equal to 10. And E is, I talked through the problem basically talking about E. Yes, there were 3 options, but we can condense it to success or not success. Number 14. You'll probably see maybe one or so types of problems like this where it takes a lot of time to do this one multiple choice problem. Every single answer choice option makes you go do separate math to check it. Now, in going over it, it's a great problem to go over because we can go over 5 different types of things with one problem. In the time span of just completing 40 multiple choice, it takes a lot of time to do it. Alright, so of the 3 attitude groups, the group with the negative attitude has the highest proportion of type A personality types. So the group with negative attitude has the highest proportion of type A. So I'm just dealing with this one. What is the proportion? So I'm going to write negative proportion of A is what? How do I figure that one out? Like whatever what? We might be done in 15 minutes. No, I think we're 24 over 43, which gives me what? Well, more than half. I can look at that and say more than half, right?
Mm-hmm.
But it's saying negative is the highest of type A. So neutral proportion of type A is what?
11.
Well, that's over half. This one's going to be more than that. And then this one, oh, these are all more than half. It's easier for me to deal with these in percents. I don't care if I tell you what they are, as long as you're following with me how to get them. This one's like 55.8%. This one's 55%. This one is 67.6%. So is negative of the 3 has the highest of type A?
No.
No. What kind of probability is that called? Where I only dealt with like one specific and then found probability or something within that one specific? Conditional probability. So it wanted, most of these are dealing with conditional probabilities, you just have to do them correctly. Of the 3 attitude groups, the group with a neutral attitude has the highest proportion of type B. Why should this part be really easy to figure out what the answers are?
Because it's just the lowest of that one.
The opposite of these. So we've got 45%, 44.2, 33.4. So would neutral be the highest of type B? Yes, because it's going to be 45%. I don't know that I'm going to sit here and waste time to go through every single one of these. C, for each personality type, more than half of the 100 respondents has a neutral attitude. Can you look at that one and tell me it's right or wrong? For each personality type, each one of them has more than 50. Well, if I have more than 50, then we're not right in the first place. So that one isn't even really a correct one to do at all. I can keep going. These are 2 different. This one says and. Let's just look at E. More than half of the 100 respondents have type A and positive. Type A, positive. Is that more than half? No. So I would have done another conditional for part D to check it, put it into the end. All right, 23, and this is our 15th one. sample of 20 random integers between 0 and 9 inclusive. Means I can't have 0, I can't have 9. She records the number of 6s in the sample. She repeats this process 99 more times, recording the number of 6s in each sample. So each time she selects a number, what is the probability that it is a 6? 0.1, because 0 to 9, that's 10 numbers. How many of them are 6? 1. So the probability of getting a success is 0.1. How many is she doing? 20. So this goes back to you guys thinking of it like this. We flipped a coin 20 times. Each dot represented 20 coin flips, but our probability of success in that situation was 0.5. We just happened to put how many dots up there. How many dots would end up being up there? 100. So we'd have 100 dots, but each dot represents a sample of 20 and a probability of 0.1. So our N is what? Our N is 20, our P is 0.1, so our only possible option is C.
How is it binomial?
Binomial switches it to success and failure, or success is 6, or failure is not 6. I think it's more important that, like, technically you could do a sampling distribution of something with this. So it really comes down to either one of these could work if they were done correctly. So it just happens to be the only one of those that work, and I think they kind of just try to throw you off with that part. When forming a test of significance by the population mean, a t-distribution instead of a normal distribution is often utilized. Which of the following is most appropriate explanation for this? I think a lot of you just did not read this problem correctly. Why do I use a t instead of a z? And everybody in here should know this one because I make you write it every single time you literally write z or t.
You don't have a sin.
Since sigma isn't null, or since we know, or since we only have s. So sample size is not large enough. That could possibly be in there with not being central limit theorem maybe. Sample does not follow normal distribution. That doesn't really make much sense right now. There's an increase in the variability of the test statistic due to the estimation of the population. Some of you are going to go through this really quick and pick this one, which I think was the most missed problem. Is this one correct?
Yeah.
What is wrong in this? What's one word is wrong? And some of y'all are going through this one too quick and think, okay, we have to use the sample standard deviation because the population one is unknown, and y'all accidentally picked that one without thinking about it. So now, stepping out of that one, at this point, what happens when I switch from, when I have to use a sample instead of or statistic instead of a parameter, that means there's going to be a little bit of what? There's going to be some type of error in the problem, right? So which one of those would talk about the fact that there's going to be a little error because we had to estimate the parameter? We have to account for the error, which means there's going to be an increase in the variability because we had to account for that error, which is why the t statistic becomes closer and closer to the z as it gets bigger. That error is smaller the bigger our sample size is. Try to do one more part. I have to sophomore restart. Oh, yeah, 28. Let me stop this and restart because I'm afraid it'll mess up our video. Y'all go ahead and read through 28, like all parts, and try to write down which piece is the issue, because reading through it's going to be most of what it takes us to do it.